it? And in the last class we discussed about the two types of waves, and those were longitudinal and transverse. And I told you the difference between longitudinal and transverse along with the different examples and drawings, isn't it? So today we'll further continue about how sound is produced. Okay, and you know that sound travels in the form of longitudinal wave. So let's see how sound travels. Okay, so how does sound travel? You know that sound travels in the form of longitudinal wave. So how does sound travel? Say you have a speaker here. Okay, speaker produces sound. So when speaker produces sound, the particles which are closer to the source of sound will get disturbed, and they start vibrating to and fro. Okay, they move forward, they come back. They move forward and they come back. So they move forward. So they move to and fro. So when this particle move, they gain energy and they touch the other particle. Now when the other particle gets touched with the first particle, okay, this again they move forward and then comes back. Again there will be other particles which are in and around, and they touch the other particle, they move back. Again this particle will vibrate to and fro, will touch another particle and move back. So how do they move? They come together and they move back to their normal position. So when they come closer, so you know this is the form of longitudinal wave. So when the particles they come closer, we call it compression. And when the particles are in their normal position, we call it rarefaction. So a sound travels in the form of compression and rarefaction. So when the particles which are closer to the source of sound, they come closer, they compress with each other, so we call it compression. And when the particles have touched the other particle with their energy, and when they go back, they come back to the normal position, that position is called rarefaction. So this is how the sound is traveled. So they move from here, they touch the particles which are closer, they move back. Again the other particle, they touch the particle, they move to and fro, and they touch the other particle. Because they gain energy, they touch the other particle, they move back to the normal position. And this is how it continues till it reaches the listener. So this is how sound is produced. Okay, this is how sound is propagated, not produced, sorry. This is how sound is propagated. Sound, however, is produced by the vibration of particle, which we discussed in the first part of it, isn't it? If the particle starts vibrating, sound is produced. And in order for the sound to propagate from source to the listener, we need a medium. If there is no medium, sound will not travel. And I think we discussed that also. In vacuum, sound cannot be heard. I gave you an example, an experiment, and that is one reason why the astronauts, they have special shoes and they use radio waves to communicate with each other on the space or the moon, isn't it? Because there is no medium for the sound to propagate. Okay. So, and you know the sound travels fastest in solids, least in gases, and lesser in liquids when we compare them. So this is the propagation of sound. So sound travels in the form of compression and rarefaction, and sound travels in the form of which wave? Longitudinal wave. Okay, sound travels in the form of longitudinal wave. So, and I gave you an example also last time that when you play with a slinky or a spring, that would be a perfect example of longitudinal wave. If you compress it, when you press it in the forward and backward position, so this is how sound propagates. Okay. Okay, now it's like a relay. When you know the first one runs first and then touches the other one, passes it to the next. So when they are passing the stick or whatever they're passing, that would be your energy. So we can compare it with the energy. They're passing the energy. So when the first runner passes the energy to the second one passes the third one, fourth one, and this is how it propagates, isn't it? The same way sound also travels in the same form, except in the circular way it travels to and fro. Okay. Now there are certain terms related to a wave. Okay, terms related to wave. And before we continue with the terms related to wave, I think there are terms which you need to know. Okay, straight away we'll move to terms related to wave. So the first one is your amplitude. The first term which is related to wave is your amplitude. Now what is amplitude? Amplitude in case of transverse wave, see, what is the upper part called? Crest. The down part is called trough. So this is your crest, this is your trough. The maximum distance a particle can reach, the highest distance the particle can reach, is called your amplitude. Okay, the maximum distance it travels, it's called its amplitude. So this is your amplitude. For example, when you play a yo-yo, so when you play a yo-yo, you throw it up or you throw it at the sideways, it reaches to the maximum point and then comes back. That maximum level where it reaches is called its amplitude. Okay, so when you just throw and then it comes back, the yo-yo, as I told you, when you throw it forward, it goes to the farthest point and then comes back. The farthest point it reaches is its amplitude here. Okay, so when the particles are vibrating, they vibrate, isn't it? When the particles are vibrating and the maximum distance it reaches when it's vibrating, that maximum distance is called amplitude. Okay, this is in case of which wave? Transverse. Now in case of longitudinal wave, what did I tell you? In case of longitudinal wave, the particles, they come closer, they move to and fro. This is your compression, this is your rarefaction. So when the particles come closer, see, when this particle is moving to and fro. Now when it goes to the maximum point, touches the particle and come back, that maximum point that it reaches is its amplitude. Okay, it goes to the farthest point, touches the particle, next particle, and then comes back. So when it is vibrating to and fro like this, okay, it touches the point, the maximum distance it goes and then comes back, that maximum distance is called amplitude. So what is your amplitude? Amplitude is nothing but the maximum displacement of the particle. So what is the amplitude? Amplitude is the maximum displacement of the particle. That is the highest point the particle can reach. Okay, the farthest point the particle can vibrate or cover is called your amplitude. And the SI unit of amplitude is, since it is a displacement. Okay, since amplitude is displacement, so SI unit will be the same as displacement, which is meter. Okay, represented by small m, meter. So what is your amplitude? The maximum displacement of the particle in SI unit is meter. Okay, the second term related is frequency. Now what is frequency? Frequency is the number of vibrations per second. How many seconds can it vibrate in how many numbers can it vibrate in 1 second? So see here, how many times can it vibrate? It goes up, goes 1. This is 1. From here again it goes here. This is your 2. Okay, the line that I'm drawing over here is 1, 2. Again, it goes here 3. Okay, this is only half. So it reaches 3 and half. See here. So how many times does it reach? Goes here and reaches here 1. From here till here it is 2. So what is the frequency here? How many times did it vibrate here? 3 times. You can see, don't count this part. See, 1 till here. Starting from here again goes down, reaches here. This is your 2. Starting from here again goes up, reaches here. This is your 3. And from here it reaches here. So it's 3. You can count it as 3 and a half. Or you can complete till here. So how many times does it vibrate? 3 times. And how many times did it vibrate? 2 times. So what is the frequency here? The frequency is 3. And what is the frequency here? 2. So what is frequency? Frequency is the number of vibrations in 1 second. Okay. Or how many times the particle can vibrate in 1 second is called its frequency. This is in case of transverse wave. For a longitudinal wave, the series of compression like how many times can it complete the compression and rarefaction would define its frequency. Okay, and frequency is the SI unit of frequency is Hertz. 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 And the symbol is capital H small z. Okay, this is how we write Hertz. Capital H small z. The SI unit of frequency is called Hertz. Okay, named after the scientist. Hertz. Hertz. And it's symbolized with capital H small z. Okay, this is the symbol. This is the SI unit of frequency. Now another one is okay, we'll not get in detail. Another factor is time period. Okay, the third one is your time period. Another factor here is your time period. And what is your time period? Number of time period means how many times it can vibrate. Sorry, time period is defined as one complete to and fro motion of the particle. Okay, what does it mean is how much time does it take to complete one to and fro motion? For a transverse wave, okay, one complete to and fro motion would be from here, it starts from here, it completes one crest and it should complete one trough. Now how much time does it take for one crest and one trough is your time period. Suppose if it takes 1 second, the time period will be 1 second. If it takes 2 seconds, the time period will be 2 seconds. Okay, so what is time period? Time period means one complete to and fro motion of the particle. That means one crest and one trough in case of transverse. In case of longitudinal, it completes one compression and one rarefaction. So how much time does it take? For one compression, that means moving forward and then coming back to its normal position. Okay, that in case of longitudinal wave. So how much time does it take for the particle to vibrate? They come closer, they vibrate, and then they come closer, they move back to the normal position. So what is time period? One complete to and fro motion of the particle. What is it? One complete to and fro motion of the particle. Okay, time period is defined as one complete to and fro motion of the particle. Up movement and the downward movement, or the to and fro motion of the particle of the wave is called time period. Okay, then there's another term which is called wavelength. Okay, before we talk about wavelength, the relationship between frequency and time period is frequency is equal to 1 by time period. So please remember this, frequency is equal to 1 by time period. What does this mean? This means that frequency and time period are indirectly related, okay, inversely proportional. So if time period is more, frequency will be less. If frequency is more, time period will be less. So they are always inverse of each other. So frequency is equal to 1 by time period. So this is the relation between frequency and time period. And the SI unit of time period will be the same as that of time, which is second. Okay, the time period, the SI unit of time period is second. Okay, the last term that we're going to discuss about is wavelength. And what is wavelength? Wavelength means the distance between two consecutive waves, okay, between two consecutive crests, or between two consecutive throws, or between two consecutive compressions, or between two consecutive rarefactions. Okay, what does this mean? Now see here, up and down, and up means crest, down means trough. Up means crest, down means trough. So the distance between two crests, the distance between the crest here is called wavelength, or the distance between two troughs are also called wavelength in case of transverse wave. In case of longitudinal wave, the distance between two compression and between two rarefaction. Okay, say this is your rarefaction. So the distance between these two compression is called wavelength, and the distance between two rarefaction, this rarefaction is called wavelength in case of longitudinal wave. In case of transverse wave, between two crests and between two troughs. And wavelength is represented by a Greek symbol called lambda. It looks like opposite y. Okay, it is pronounced as lambda. Okay, this is how it is represented, lambda. The symbol of wavelength would be a Greek symbol, which is your lambda. So the distance between the two crests, or between two troughs, or between two compressions, or between two rarefactions is called wavelength. And wavelength is a distance, isn't it? Wavelength is a distance between two crests, or two troughs, or two compressions, or two rarefactions. Since it is a distance, so SI unit will be the same as distance. And what is that? Meter. The SI unit of wavelength is meter. Okay, the SI unit of wavelength is meter. So these are the four important terms which is related to the wave, which you need to know. And in the next class we'll talk about the characteristics of sound. Okay, so I hope this much is clear, which are the few terms which are related to wave, that is frequency, time period, wavelength, and what was that? Amplitude. Okay, so the four important terms we've learned today. Please revise it. If there's any difficulty, please do ask questions. Thank you.